The name of the attack was the NSA infiltration of TOR users. In short, what happened during the attack was that the NSA identified TOR users and was able to exploit their systems to interact with the NSA's own secret server, which is codenamed Fox Acid. And those connections allowed them to track the internet usage of those TOR users via a manipulator in the middle attack or man in the middle attack in conjunction with a race condition. It's important to study this attack because this attack demonstrates the capabilities of a man in the middle or manipulator in the middle attack and how the implementation of such an attack stems from vulnerabilities in common everyday software that's used by a large population of users throughout the world. Okay, so to understand this attack, we need some background information on, well, what is TOR? And so TOR is a browser bundle that disables some features as side effects like plugins and QuickTime, which essentially slows down the loading of websites. But what TOR does as its benefit is it allows all TOR users to look the same. In other words, you could differentiate between a regular internet user and a TOR user, but when you start looking at specifics of an individual TOR user, you wouldn't be able to find any information because all TOR users look the same. And so it essentially allows obscurity of the identity of a TOR user. And so this was initially developed by the US Navy, and the initial project looked at privacy and anonymity of the internet, because on the internet you don't have too much privacy, and so it was of the interest of the US Navy to find that privacy. And so this project was highly funded by the public government agencies and companies because they have an interest in preventing the misuse of these sorts of technologies. So the way in which Tor actually makes sure that the identity of its users are obscured is through this interesting network diagram. So Tor, you start with a Tor user, someone on their PC who wants to access Tor, and they'll send an initial request out, and this will go to a bunch of nodes. And sometimes these nodes are called relays, and there's hundreds of thousands of these that any one given request will go through. And so I'll just show that with ellipses, and you'll eventually get to this final node, which will connect over to this Tor server. And so this is where the request actually wants to go and end up. And so what happens is that each of these connections between the nodes and the Tor server and the user, all of these connections, are actually encrypted. And so we have hundreds of thousands of connections. And each of these connections are heavily encrypted. And so that adds to the obscurity of this system. But furthermore, we have limited path knowledge. So each of these nodes or relays has limited path knowledge. So if I was at, say, this node here, the only thing this node knows is where it's going and where it came from. It doesn't know anything about, say, this node or any of these other nodes that might be in the path. And so that adds even more to the obscurity of the identity. And so what happens essentially is that through all these countermeasures, we start seeing that the start position and the end position are not easily connected, right? So start and end are not easily connected, which is really the point or how we can obscure the identity of the user, which is really the entire point of Tor. And so this might make you wonder, who are the actual users of Tor? And so there's two types of users. There's good users and there's bad users. The good users are the legitimate intended purpose that the Navy actually created this for. And those are people like journalists, law enforcement, and people that are under, censoring regimes. Because if you obscure their identity, they're much more open to talking, and kind of the flow of information is easier that way. The bad users are people that are using it for things like arms dealing, drug dealing, and human trafficking. And so those become synonymous almost with the idea of the dark web. And in fact, Tor is a means of accessing the dark web. And so it's important to remember that there's both good and bad uses of Tor. The other thing to be familiar with is the Fox Acid servers. And Fox Acid servers are basically these NSA servers, NSA-based servers. And what they did was they would inject the user, the Tor user, with malware, or rather their PC with malware. And so you'd have these Tor users, and they would somehow connect to the Fox Acid server, which we'll go over in the attack vector section. And once they connect initially, they would be injected with malware. And what happens is that over time, these Tor users that were infected, their PCs would connect randomly to the Fox Acid server again, and the Fox Acid server would send them updates. And those updates would ensure that they were compromised long term. And essentially what this allows you to do is it allowed the NSA to have eavesdropping privileges on the Tor user. And so that allowed any of the activity that the Tor user was doing on the internet, whether that was with Tor specifically or not with Tor, the NSA could track all that information and keep that in a database. And that's essentially what the NSA did. All right, so now we need to talk about the attack vector. And so the attack vector for this attack can be broken into two large kind of sub-goals. And so the first one is to just find Tor users. And the second one is to connect those users to the Fox Acid servers that the NSA houses. And so to do number one, you can start with all the internet activity that is collected and sent to the telecompanies where those users are. So basically, all the users of the internet, they generate data, they get sent to their particular telecompany, so something like AT&T or Verizon or whoever provides your internet. And so for the NSA, those are the US telecompanies. And those US telecompanies have a connection with the NSA because the NSA has elevated privileges. And so what that allowed them to do was the NSA was able to send HTTP requests to TOR. And from there, they were able to generate a list of NSA fingerprints. And once they've had this big list of NSA fingerprints of their suspected TOR users, they were able to run a bunch of data analytics and find particular TOR users. And so the significance of this is that we've kind of undone what the purpose of TOR is, in that TOR is, you can easily distinguish TOR users from regular internet users, but finding the specific TOR user out of a group of TOR users is not so simple. And so that's what the data analytics and the NSA fingerprints are doing. And so by doing this, we've now essentially fixed the first sub-goal of our attack vector. And so the second part is now to connect these people to the Fox ACID servers. And so the NSA went about this in a couple different manners. So the first one was to just use a man in the middle. And this was essentially used whenever the user was actually connecting to Tor. And so there are some times, now that we have a list of Tor users, we know they've connected to Tor, we know other times they're not going to be connecting to Tor. And so for those times, we have a race condition that we can use in conjunction with a man in the middle. And that allows us to exploit the users even when they're not connecting to Tor. And so when we look at the man in the middle, you start with a Tor user, and this follows kind of the most basic format of a man in the middle. And what we have on this end is some TOR functionality. And usually the user would send requests to the TOR functionality, and that would send something back. But in this case, we have our Fox ACID server in the center. And the user would connect here, and this would connect back over, and we'd be able to relay everything to TOR, and TOR would relay back to us. But what ends up happening is that the NSA Fox ACID server is able to eavesdrop on that entire communication pathway. And so what allows this to occur is really the exploitation of a vulnerability in Firefox. It's the E4X vulnerability, and the NSA codenamed the exploitation of this using some software they developed called Egotistical Giraffe. And what that allowed them to do was to take advantage of the E4X vulnerability and inject the Fox ACID server connection, so that the TOR user was being connected to the Fox ACID server, and this man-in-the-middle attack could occur. Now, when you put this in with the race condition, what happens is you don't need a connection to TOR necessarily, but it functions kind of the same way, in where you have a TOR user on one end, and now you have a legitimate website that the user is going to connect to. So they're originally just going to connect and get a response back. Now what ends up happening is that the NSA has these websites that are strategically located throughout the internet. And so what ends up happening is that the user will connect to this website that can relate to the legit website and basically function the same way the man-in-the-middle attack functions. But what ends up happening is with the strategic location, when the TOR user tries to connect to the legitimate website, the strategic location allows the NSA website to appear faster than the legitimate website, thus the race condition. And so the TOR user connects to the NSA website rather than the legitimate website because of that timing and the strategic location. And so the entire communication is now eavesdroppable to the NSA. And so the NSA, regardless of which pathway they take, is collecting information on the TOR user's activity, and it stores that into these large databases, which they can analyze further later on. And so that kind of concludes the entire attack. The consequences of this attack really affected TOR users because their usage was infiltrated and exploited, and thereby the anonymity that TOR provided its users was completely undone by this attack. So the main reason that users would use a TOR bundle, the TOR browser bundle, was completely diminished. And since this attack had been made, there have been attempts to correct the vulnerabilities in Firefox, which would stop the NSA, which did stop the NSA from gaining access to TOR users' computers. But the NSA did mention that they were confident that they would find an alternative means to achieve the same result, even with this vulnerability being patched in newer versions of Firefox. So in conclusion, the current state of affairs is that TOR is still largely used. It's still a largely used browser bundle. It remains highly involved in the darker ideals or in activities of the dark web like drug dealing and arms dealing. The information about this attack was gained from a whistleblower, so not much new information has surfaced regarding the current state of affairs. However, from the statements that the NSA made, it can be concluded that the attack is still in play, since they said they are working on finding new vulnerabilities, even with the patch in Firefox that Egotistical Giraffe exploited. And although the technical details might have changed, the attack was most likely still in play. So who should be taking responsibility? The NSA has clearly stated and taken responsibility via the whistleblower report that was put out. And some of the lessons that were learned from this was that it's hard to have true anonymity on the internet, especially when attackers have higher privileges than the end users. And so those elevated privileges kind of diminish the power between the end user and the people who are exploiting that. And here are the citations that were used in creating this presentation. Lastly, some further questions. Seeing as this attack was made known to the public due to a whistleblower, do you believe that other government attacks on the public should be made known to the public? And if you were a TOR user, would you continue to use TOR? Would you implement any new security measures for your connection?